Imagine you are an aspiring drone pilot living in the mountains. You get ready for takeoff, and suddenly, no GPS lock. You can't carry out your autonomous reconnaissance missions. If you have ever had issues autonomously flying without a GPS lock, meet today's sponsor, ANPC. ANPC is a custom alternative to the instrument landing system called TLS, or the transponder landing system. TLS works by interrogating transponders mounted on an aircraft in a certain region. Each transponder responds with its squawk code, a unique identifier, which the system uses to triangulate the vehicle's position using the timing of the received response. This allows TLS to continuously track and display the real-time location of any vehicle in the area equipped with a compatible transponder. While this usually is used to create a glide slope to send to the pilot of each aircraft, it can be used by our drone for autonomous control if relayed on a data uplink. To learn more about TLS, check out ANPC's website using our affiliate link. To develop autonomous navigation using TLS, three main things needed to be done: the development of a quadcopter drone capable of autonomous flight, coding a custom ground station decoder for the incoming TLS packets, and a way to integrate the two. The ground system decoder consists of a Python script that reads *48 packets and repackages position data into a readable Mavlink package to be sent up to the drone for ArduPilot to run off of. The drone itself was custom built off of a Holybro 650mm frame, 280 kilovolt motors, and 17-inch props. It weighs in at around 9 pounds. The navigation system consists of a Pixhawk 6X, GPS, telemetry radios, and the transponder necessary to be tracked by TLS. Flight mode tuning took place over 2 weeks of flight testing at a local park, and after a few errors, we verified that it was safe to fly.
Oh, that's good though. That's what you want. No, that's not what you want. No, no.
Oh, nice drone. I wonder who's piloting it.
You talking to me?
Wait, if you're not piloting it, wait!
For integration, Mimic TLS data was fed into the ground control computer, which then fed into ArduPilot. Here it can be seen that the ArduPilot thinks it is in two different places, Seattle and Hood River, depending on its source of data. The toggle between GPS and TLS is on the radio controller held by the pilot, allowing for switching at the pilot's discretion. Because this project was built off of ArduPilot, it can be integrated into other vehicles run off of the same open source software, which is widely used in many parts of the world. This opens up a lot of possibilities for any use that autonomous flight may have in areas with degraded GPS signals. This project can be expanded to have autonomous drones calibrate TLS without the need for skilled drone or aircraft pilots to allow for quicker deployment of these arrays. Thank you to our sponsors and mentors for their help in providing technical insight and ensuring our safety throughout the design and testing process.
Yeah, Catherine. Yeah, Catherine. Good morning.
Tonight, we leave for Hood River again for our final test, bringing everything together and interfacing with ANPC's network.